Hello friends, this is Swagatam and this is my first video that I am making on my projects. So thank you for watching this video, and let me give you a little bit brief about this project. So here basically we need to forecast the energy requirement. So we have the data already, so I will show you about the data. So here basically we have loaded the data under DF and DF test, data frame and data frame test. So this is the test data. The DF test is the test data and DF is the train data. So we can see here this is the test data. That is how it's looking like. Row ID is present there, and the other feature, that is date time, is present there. So date time is basically the feature that we have here. From there we need to predict energy. So this is what the DF or the train data it looks like. So here we have only one feature, date time. On the basis of that we need to predict the energy. So I thought like it's very important for me to segregate or basically do some feature engineering on date time and see if we can find out some relationship between date time or and energy. So before doing that, I have also checked that is there any null values that is present there or not. So I have seen null value is present there under energy. So you can see here this is how it looks like. So these are the datas where total 1900 rows that is showing here, so where energy is missing. So I thought of filling up them instead of doing a fill. I tried of doing that in a different way, so I'll show you or talk about it later on that. So but on the basis of the basically the features, we will be filling up this energy because 1900 is a very big number. I do not want it to miss out that part, because whenever will be training our model, that a little bit of information will be very important. Why, I will tell you. We will be going through that. So here I just looked at the data. So yeah, you can see here this is where we can see that missing value 993092 for energy, but for the other one 94992. So there is a huge number of missing values there, but I do not want it to miss on this part. So I will tell you, as I told you, that how we will work on this missing values. So before that, we can see here this is what I have done the feature engineering. We can see here from the date time I have taken year, month, date, time, week and day. So that is how I have got the features from the date time features. So this is how it looks like. You can see here row ID, date time, year, month, date, time, week and day. So from here, year, month, time and week and day, this can be a very important feature. What I have seen here, basically there is a trend that has been observed in terms of month, in terms of time, in terms of week, in terms of day, and in terms of year. There is a very, I would say, like a proportional relationship that is present there, that I'll be showing you guys. So as we can see here, so this is the, we can see here year versus energy graph. So we can see here it's very much proportional to each other. So I could see like it's a very good correlated features with respect to energy. So how have I handled that one? That's what I'll show you. Apart from that, I will also show you one more. So you can see here this is the relationship between energy and the day. The similar trends has been observed in terms in case of other features like year, in terms of sorry, other features like month and week and day. So it's the similar features. So I thought of, okay, when energy has a very good relationship with the year, so we will treat them in a different way because these are more like correlated. But when it comes to the month, time, week and day, they are more into like seasonality relationship that is present there. So that's how I have treated them. I will show you what I have done. So here I have segregated data into two parts. The one part is year, the other part is month, time, week and day. These are the categorical features that we can see here. So but we just looked into the data. We can see here all are not converted because int is there, int is there. So I just convert the features which I am considering as a categorical features into a categorical. So here, not here, I'll show you. Yeah. So Yeah. So after that, what I have done, so after that, the numerical features I have done is standard scalar here. So choosing standard scalar has a very important point here, because here, whenever we are converting something into the scalar, it will be easy for me to predictions also. And as well as the standard scalar, why it is important with respect to the min max scalar. In case of min max, because whatever in the train data is present there, okay, but the value of the test data will be more, because up to 2018 I think this data was given, and from 2019 the data of the test data will be coming. So that's why I have taken standard scalar. So you can see here how this data will be looking like, train data and test data for both of them. So yeah, we can see that. So that is how it looks like even after converting into the scalar. So here I have converted the features cat calls into the categorical features, you can see here. So again I just checked it before running the thing, so you can see this is how it looks like. And after that, what I have utilized, I have used one hot encoding on these categorical features. And then I have loaded cat boost here, as you can see here. Then actually I tried each and every model, but cat boost has given me very good result. But here is the main trick that I have applied. One trick is this, we can see here np log. So I've done a log transformation, as it's a regression based model. And the second part, what it is there, you can see here, I have segregated the train data and test data in a two categories. One with here, the other one is without here. So what I have done, so as I said in the earlier part, there is a good relationship that we have seen between here and our target variable energy. So what we have done, I have used linear regression for that model. And you can see here, so what I have done for the model 2, I have used cat boost. So on the residuals of the like after predicting the value, whatever is the residuals, I have trained my model 2 cat boost on that. So that's how I got the good result. And here let me tell you, this you can see here n estimated is 2000. So for choosing that also I have used grid search cv. That is also there in the code that is present there in the below. I'll give you my github link, you can load this code and you can go through it. In case if you have any other queries, please let me know. Thank you, have a nice day.